So let's see some basic SQL data types. So in the SQL data types, we have some basic data types. So for example, like we have numeric data type, which we can use to represent number. So numeric data type can be integer. Okay, so means integer type. So we can write integer like just integer or int. Okay, we can write both. For example, like the number. Okay, so we may want to d number to be just a number. Okay, so we can write d number int. Okay, or if we want, we can also write integer. Okay, so there is another numeric type, small int, that represents small integer number. So another basic numeric type is real, which you can use to represent floating point number. Okay, real or floating point number. For that we are going to use the data type float or real. Okay, also there is another data type double precision. Okay, both all of them can use the floating point number. So we may also use the number with some format. For example, if we want to specify the precision, in that case we may want to use decimal with ij. Okay, or dcij or numeric ij, that will specify I total total decimal digits and j after decimal point. Okay, so I call the precision and j call the scale. So these are the numeric type. All right, now we have some basic character string data type. For example, we have as a key string data type, we have character. We can represent as character or character. Okay, like with char n or with char or with character n. So this one is to represent a fixed length data type. For example, let's see you want to specify the attribute SSN. Now we know that SSN is a attribute which takes exactly 9 character. Okay, each SSN has exactly 9 character. Okay, so 1 2 3 4 5 6 7 8 9. Okay, don't include them. So 1 2 3 4 5 6 7 8 9. So I'm just specifying something here, but we know that for SSN is going to be exactly 9 character. Okay, so these are the example of fixed length. Okay, where n is the length of the character, we can exactly specify what will be the size of the character. Okay, and another example is USA phone number. Okay, USA phone number is also, we have 3 digit, then 3 digit, then another 4. Okay, that's exactly 10 digit. Okay, now we can specify phone as a numeric data type, but if we want to specify phone number as a string data type, we can actually specify that, and we can specify exactly with the length of the data type. Okay, with exact length we can specify exact length 10 digit. Okay, so in that case it will be it will be actually much more feasible for the user, so that they cannot insert a wrong phone number. Okay, because all USA phone number has exact 10 digit number. So another string type can be variable length. Now for example, we are talking about name of a person. Okay, or address of a person. Now name of a person, address of a person, they could be actually any length. Okay, the length of this attribute could be any number. All right, so in that case we are going to use varchar n or char varying n or character varying n. Okay, so here why actually we are going to use n will specify the maximum length. Okay, n will specify the maximum length. Now for example, I have a attribute name. Okay, I can specify that as a varchar 30. What does it mean that I am specifying that the name can be at most 30 character? Okay, at most 30 character. Now my name may take is much more smaller length. Okay, my name may have much more smaller length. For example, the name is say only Madhuri. Okay, the name is only Madhuri, so it has 1 2 3 4 5 6 7 character. Okay, so if the name has 7 character, in that case it will take only 7 character. Okay, now depending on the length of the value, okay, depending on the length of the value, the memory is going to take only that length. So Madhuri has only 7 character, it will only allocate 7 characters in the memory. Okay, but this number will tell that at most I can insert a value with that many character. Okay, the maximum length can be 30 character. Okay, so now let's go back to our example. Here for dname we are saying that varchar 15, so that means the maximum length of dname can be 15, but it can be also small. So if the length is small, the space, okay, the storage space for dname, this is going to take only that amount of storage space. Okay, alright, we talked about basic numeric data type and basic character data type. Character data type can be fixed length if you exactly know the length of the value, or it can be variable length. Okay, now we can have basic Boolean data type. Okay, so basic Boolean data type we can actually specify with bit or bit varying. We can have also some other large object data type. Okay, say if the data type is binary large object, we can use this BLOBN. So the large object data type can be used to store attributes that represent image, audio, video, or other large binary object. We may have also character large object, like it can be used for audio. Okay, so CLOB with the length of the data type. It can be used attribute character large object. Actually it can be used that store articles, news stories, text file, and other large character object. So another data type we can have date. Okay, for example, say manager start date. For that actually we have a exact data type known as date. Okay, the data type name is date. So it can use standard date format. Okay, for example, 4 character for y, 2 character for month, 2 character for day. Okay, for example 2010 January 22. Or we can also specify some older formats such as like January 22 2010. Okay, now here values will be ordered, okay, with later dates larger than the earlier ones. So we have also another data type, time data type. So we can use the generally it use the standard time format. For example, hour, minute, second. Okay, so 2 character for hour, 2 character for minute, 2 character for second. For example, that represent like 15 is the hour, so it will represent 3:20 p.m. and 22 seconds. Okay, so if we want to have actually more precise second value, in that case we can use a time with parenthesis the value I. Okay, it will include the additional I minus 1 decimal digits for fraction of a second. For example, time 5 is going to give you the time with hours, minute, and you can see the second like 22.4 5 minus 1 4 decimal digits for fraction of the second. Okay, another data type is timestamp. Timestamp is actually combined with time with the date. Okay, a date combined with time where default I equals to actually 7, okay, is the timestamp. So if we use the timestamp, it will give you the date and time. and default I equals to 7, so by default it will give you after the second it will give you the 6 digit fractional number. Okay, if we want I value greater than 7, we have to specify that. Interval is another data type that will represent a relative year, month or day time. Okay, so for example 2 years 5 months, if I want to represent them like as an interval, say 2 year 5 months, or I want to represent like 5 days 20 hours 3 minutes 22 seconds, for that I have to represent using interval data type. So other data type also exist, so these are the most common data type. Okay, now we can go back to our company database. Okay, so this is our company database schema. Okay, and here we have all the relational schema. All right, so all the primary key and foreign key information is also there. Now we can write appropriate create table query to define each of the table. Okay, for example employee, the name of the table is employee, and we can see all the attributes here, and we have to find the appropriate attribute name is there, so we have to find appropriate data type and appropriate domain constant for them. If we want to think that there is going to be a constant for them, we are going to choose them. Otherwise we can just choose the foreign key and primary key. So for example f name, we can see that f name is going to be a varchar. Okay, so the most appropriate data type for first name will be varchar. M in it can be actually like we may want to specify character and the length of the character. For example M in it is going to be just 1 character or 2 character, we may want to specify like that. Okay, L name, the appropriate would be the data type character type, or sorry varchar type. Okay, for last name appropriate would be varchar type. Okay, SSN, so we can make SSN a character with exactly 9 length. Okay, or we can also make SSN with integer. Okay, both is possible. B date, the most appropriate will be date. The address, most appropriate will be varchar. Sex, we can use like varchar. Okay, now also if we want to use only female or male, okay, in that case we can just use like 1 character. Okay, like character 1. So that depends on how we want to represent each of the value. Okay, if we want to represent the sex using only f for female, m for male, then we can only use character with 1 character. Okay, otherwise you can also use varchar, by which we can represent them as a male or female. Okay, so salary, it should be integer. Super SSN, it should be same as SSN. DNO, it should be a number. Okay, now here this is all given. Okay, so you can see that f name, it's varchar. M in it we're saying just it's a character. So if there is so if there is no number specified, it means by default it's 1. Okay, means it is going to be only 1 character. L name is varchar. SSN, they are specifying that as a character with 9 character. Okay, B date, address varchar. Sex, it's character, they are going to specify that with F and M. So salary, decimal 10(2), so it can actually support decimal number, I mean the floating point number. Okay, your salary can be like 10,000 like okay, all right. Oh, your salary can have actually decimal point, so that's the idea. I mean fractional number. So super SSN, it has to be actually same as SSN. So we'll talk about that. Why? Because super SSN, it's actually from the table definition. You can see that the super SSN is actually a foreign key which is referencing the SSN. Okay, so in that case they have to be actually same same data type. They have to be actually same data type. So DNO, it's integer. Okay. Now for some of the constraint we are for some of the attribute we are specifying the not null constraint, but not for everyone. Now it depends on how we want to have our table. We are saying that fname and lname cannot be null, but for some employee minute can be null, right? So for some of the attribute we have to actually allow null value. All right. So bdate, it can be missing for some of the employee. If we think that it can be missing, we have to actually allow null. All right. So but if we think that we do not want to allow null value, in that case we can we can actually specify the not null constraint. All right. All right. So employee has primary key, which is SSN. So we are saying primary key is SSN. All right. Now how many foreign key employee has? Employee has for that we have to actually look at the arrow symbol. Okay, employee has these two arrow symbol. One foreign key is super SSN, another foreign key is DNO. Okay, so for that we have to specify this foreign key because they are the foreign key of employee table, and we need the information from the referenced table. Okay, so super SSN is actually referencing the same table but the SSN attribute, and DNO is referencing the department table D number attribute. So let's see. The foreign key super SSN referencing employee SSN, and foreign key DNO, which is references department table D number attribute. Okay, and that will end our table definition. You can see that in the table definition we are listing all the attributes with their data type and constraint. Okay, then we are going to list the primary key and a list of foreign key. Okay, so let me show you the example of department location. So in the department location you can see that here we have underlined under two attribute. So remember, every table will have only one primary key, but the primary key can contain more than one attribute. So it is going to look like that. For department location we have D number integer not null, D location varchar not null. So the primary key, it is actually one primary key, but the primary key contains more than one attribute. So D number, D location, all together it will be the primary key. Okay, so it means that all together D number and D location value has to be unique for department location table. So let me give you an example for department location where actually the primary key has more than one attribute. So we have D number and D location. Okay, so as the primary key contains these two attributes, that means altogether these two value has to be unique. Okay, these two value has to be unique in this table. So for example, the D number 1 can have actually multiple location. So each department can have multiple locations. So let's see, Colorado, one has location Texas, and one has location so Mississippi. Okay, department 2 has location Colorado, and department 2 has location California. Okay, now you can see that if we consider each of the tuple is actually combining for each of the tuple containing these two attributes value, they are unique. So here one CO, okay, as these two are the primary key, we have to now find out that the value for both of the attribute. So one Colorado, here it has the department number 1, but the D location is different. Okay, again for this one, so it has Colorado, the same state like here, but the department number is different. So combining these two attribute value, they are going to be unique okay, in the table. The values are going to be unique in the table, combining the values of the two attributes, okay. But always remember, one table will have only one primary key. Now in this table, D number is the foreign key, which is referencing department, D number of department. So we are specifying D number is the foreign key, references department D number. So I believe now you can write the create table query for each of the table, okay. So you can look at them, or you can try to write the definition for each other table. For example, project works on independent by yourself, okay. Then you can actually look at the SQL statement here, and you can find out whether your answer was correct.